Hi everyone, I wanted to take a minute to show you the new CNC that I've been working on for a little bit. A little bit haggard today, it's been kind of a long one. Here's what I got. So it's the same as the other one, the same version, but it is a little bit longer. Here you can see, I guess, maybe what you might call the front. A little bit cleaner looking than some of the others, so we're getting better. I have some ideas on how to change it a little bit. I'm going to try to get the speed up. The accuracy is good. We were doing an accuracy test the other day, and we're off and on within a thou or three. Okay, so here's a program I run. It's just a 3-inch square. I'm just going to have it cut air for a little bit. So this is a little bit new. I wanted to do something kind of cool here. So the same layout are driver boards here, right? And here's the PlanetCNC control board. Sorry if my face got kind of close to the mic there. Power supply and such. Routing the wires. Try to do the best job I could. Let's see if you can see that. Keeping everything away from everything else. So I'm using right here for the control signals coming in. This is just your typical stranded 24 gauge, solid 24 gauge wire you get from everywhere on the internet for electronics projects. And then I have some, I think this was the 18 gauge that I was using here. And after I used this, then my 22 gauge stranded came in. So that's what I'm using now. It's a little bit easier to work with. No problem with the current. 22 gauge is what the NEMA 24 steppers use anyways. So anyways, that's kind of a nice look. I want to do something to cover this because here's a thing to note. If you're building your own, it becomes kind of easy to forget little things like this. This right here, this is the state, so this is 120 volts in right there. So that's kind of a danger, so we'll want to do something to cover that up. This, by the way, is not missing it's missing a pin, but I just doubled it up right there, no big deal. We tested this. They're not 3 separate rails internally. They're all bonded together, so no big whoop. Okay, so we'll go ahead and give this a shot, see what happens here. So I haven't zeroed it out yet, so I'm going to bring that down a little bit. It's about where it'd be normally cutting, I guess. And then with the PlanetCNC USB controller software, you just come up here, hit 0, so then all of our numbers are zeroed out right there. So if you are familiar with Mach 3, this is really similar. I feel that I like it a bit better. You can see over here, here's your G code. You can click on different lines. It will show you where it's at and it will light up. So if you ever do need to stop the thing completely and come back, you can start it right from a line number, or if maybe line numbers have changed because you had to redo something and the line numbers don't match, but you don't want to have to rerun the whole program all over again. You can watch, let's see if you can get in here. So you can watch right where the red line is, and you can say, okay, well, I was a little bit further along, I was a little bit deeper down in the cut. Let's start from, say here. All right. So I'll zero it out, I'll hit go. That's it. So it's not moving real fast here. The idea is that it would be cutting aluminum, so well, we'll see how this goes. Here's a couple other things on the topic of cutting metals and things. This is a refurbished Makita. You can find it on Amazon right now, early, what is this, April 2017, for $85. We're going to see how this works. Normally I get the, there's some spindles. If you go to Amazon and type in CNC spindles, you're going to see all of these ones there. The variable frequency drives, they come with the VFD, the spindle, and a lot of times they come with a holder and a collet set and things like that, right? varying from, I don't know, 150 to 450, depending upon what options you want. So before I got an ER 20, maybe, I think it was. Maybe it was an ER 60, I don't remember honestly right now. But I liked it a lot. It was water cooled. The VFD is kind of big. So this time I'm going to try to get a I'm going to get an ER11, which it'll go up to a collet size of 1/4 inch, and I'm getting an all metric collet set that comes with it. So that might be, I'm pretty metric in the shop here anyway, so I'll probably be that'll be a good reason to shift over to at least a good supply of metric end mills and such. So let me go over this again. I've had my other video where I was running around a little bit more crazy, like showing the parts and pieces. So let's see here. So the NEMA 24s. So here you have these. I get these from Steppersonline. They're about $25 a piece. That is a Chinese company. The shipping is a little bit more, but when we buy them in bulk, when we buy so many of them, it's entirely worth it. And then we have the coupler right here and reducer. So we're going from an 8mm shaft down to a 1/2 inch. Except if you buy these online, it doesn't say it goes from a 9mm down to a 1/2 inch. It's, or excuse me, 8mm. It says 8mm to 12.5mm. So you know, get your metric on. And let's see. So then we have an Acme 5-start 10 teeth per inch lead screw that runs over through here, runs over to the other side. And then what we have over here is a little collar trap to hold this bar right here from shifting side to side as this is going to be pressing into the material, right? So the coupler over there holds it fine that direction. This way, if we didn't have the collar right here, this rod would just go shooting right out, right? So and then also in this plate, we have our 1/2 inch inside diameter bearing, but we had to trap it inside of this. So this is recessed just a little bit. It's basically an interference fit. We have to hammer it in place. So now we know it's good, it's solid. It's not important that I need to keep it from falling out, because this will do the job of keeping it from falling out. I want to make sure that this bearing is perfectly centered. So when the lead screw is going through there, I know that it's true, I guess, right? So that's basically the typical setup here. If you can kind of look in here, I'm going to kind of zip you around. Inside there is an anti-backlash nut. I've been getting these ones recently from this place called IMService, which is, you know, whatever kind of awesome name that is. But I can get the anti-backlash nuts for, I think they're about $16 a piece there. If you get them from other places online, you might even make your own, as a matter of fact, right? I just didn't want to do that with all the other crap that I'm making. Anyways, gosh, I can't hardly see that in there. I don't know if you can see it. So anyways, let me go right into the other side here. Sorry for the, again, whipping around. Cool, there you go. So there's the anti-backlash nut. Normally they're about $25 a piece. And, you know, as far as things go, nickel and diamond to death on one of these mills, I need 4 of these, right? Because I'm using, let me back up over here. So you look right here, I'm running 2 motors to keep the Y, I'm calling this the Y axis, by the way. So to keep the Y axis nice and even and straight and no twist torquing or anything, I'm using 2 lead screws and 2 motors coming off of one driver board, by the way. Anyways, so that means that I'm going to need to have 2 anti-backlash nuts on either side there. I'm going to need the one for the X-axis and another one for the Z-axis. So there's $100 just in anti-backlash nuts. So yeah, wherever you can save, you know, the better. So other mechanisms of importance, I guess. If I can show you right inside there, there is a little needle bearing thrust bearing. You really want to get something like this just right down inside there. That is going to help your wear. There is another one that I can't show you, that if you could imagine, just make this transparent, there's another one under here. So people, it seems like, especially in classes and just anybody I'm talking to about this, they understand a thrust bearing here because of the weight pulling down. What they don't understand is this unit here is going to want to push up when your mill goes into the material, right? It's going to cut and it's going to go into it, but you want to have a good solid force. So you want to have another anti-backlash nut on this shaft that's running through here on the other side right here. So if you imagine right underneath this shaft, right on the other side here, there's another thrust bearing, and then there is another one of these collars, just like this right here, underneath right there, holding it all in place. Some maybe obvious structure that's here to talk about is our fully supported rails that we have. So these are the 12 millimeter 600 millimeter long fully supported rails, and then down here I think these were the 1500 millimeter I got. At any rate, you can get a set of these for pretty cheap online nowadays. Once upon a time it was pretty cost prohibitive, but these 600 millimeter were, you get 2 of these and 4 of these slide blocks right here. Sorry, I want to say it was about 150 bucks. I'll put it up here somewhere. Okay, so again, if you look around here, that's going to be a bit of your money right there. On top of the fact, you know, all the 80/20 or Bosch, you know, if you get this 80/20, you want to do this, by the way. If you're going to build a frame for this thing, go with something like this 80/20. It's really nice and straight. If you try to weld this, I'm not going to say you're not going to get it. You know, you guys could be super pro welders. I've been welding for a very long time, but not like in any professional capacity. I stick metal together, right? And we've tried it before, and I couldn't get it to go right. So the 80/20 is really nice. Anyways, that's going to cost a lot, especially if you do this table. Look at this table here. I'm really happy with this. It's not locked in place yet, but that's probably a few $100s, a couple $100 worth of 80/20 right there. Anyways, the rail, you know, this rail right here, again, this is going to be, you know, 175, close to 200. I don't know for this side here, the other side up there, and the Z. Some other things, thinking structurally, is what I'm kind of trying to focus on first here. Originally, we used material. We used a thinner aluminum for a lot of different pieces. When we cut them small, they didn't seem really flimsy. But when we put them all together, it just started to stack up, and things got weaker and weaker. So if you look now, I'm pretty happy with this. And of course, you know, you could go more. But that's kind of the engineering things, right? Is I could go 1 inch, right? We could go 1 inch. Well, screw aluminum. How about we go steel, right? We go 1 inch steel everywhere, right? It starts to get pretty heavy and pretty bulky. So the engineering in things is the reduction of size, weight, and all of that, right? So going with the 1/4 inch right here, 1/4 inch plate here, all over, 1/2 inch for the mounts up here. I think that's the way to go. This unit right here, if you think about this, we got a 1/2 inch, or sorry, we have a 1/4 inch plate, and these fully supported rails now become, what is that, about sticking off about 3/4 of an inch of a steel rib that you've just added to this structure right here. So that's this feature right here is very stiff. The only slop you're going to get in this is the slop that might be inside of these bearings here, and so that is probably the latest concern. If you want to reduce slop in this, you know, think about changing your separation here. The more you change the separation here, though, the less travel you're going to get on your Z, and so then that means that maybe you want to make the thing this longer and all the rest, right? Totally fine. So next I want to talk about these gantry side plates. These are also 1/4 inch. These might be, I could maybe make these 1/2 inch. That could be good. More money, of course. But what we've been doing lately, which will be something I'm going to add onto this still, is now when I machine these out, I include a set of holes right here, because what we started doing was tapping in just piece of you know, angled aluminum, and we just knock it in here and make a stiffener out of it. and that's going to help this a lot. Now, I don't want to say help it a lot as in it's wiggling all over the place. It is pretty good. It's pretty strong, but I mean, I can shake it, but I don't know. I'm really moving the whole table here, just rocking around. If there is a weak link here, though, I would say that this is the one, and so reinforcing this is going to be kind of important. Maybe important, I guess, right? I'd still do it if you can do it. Now, I could have skipped this hole, so this is like a personal choice. I didn't want to have a solid plate there because, as you can even see how I'm moving around here, I wanted to be able to see. I want to be able to see that end mill wherever I go around here. I don't want to have any kind of major blind spots when it comes to watching the cut. You know, if I'm traveling around here and I'm looking around from side to side, I want to try to minimize, you know, the amount of crap that's in my face all the time. It's not necessary. You could solidify that. So here's the next feature. It's not exactly structural, but it kind of is and will be more. This piece is it's the same thing you saw on the gantry side plates. It's the end of the It's the end of the lead screw. We have a collar here, and then again a interference fit smashed in bearing right into there. So this plate we just take and we slide it into the 80/20. It works fine. And I don't mean fine in a bad way. It works acceptably. It's nothing that we're going to have a party about it working or anything, right? But what we thought the other day, what I thought would be good, is to take this. If we took this, we already have, you know, if you look at the look down here, you got this solid plate, right? Just shooting cleanly all the way down here. What I'm thinking is take this right here and run another 5-inch aluminum plate, whoops, lost the camera, all the way across here, and have the ends of the plate just sticking out a little bit, and put the end plates and the same over at the other end. We got the exact same thing down there, and that's the motor mount over there, right? We'll zoom in over there, right? Okay, whatever. Gonna make everybody throw up. So I think that'll be neat, and then I could get rid of this as well. So this beam would come out, and I'll just have another plate, just like this one here, spanning the distance. I kind of take that back a little bit. We'll leave this in here because it's nice to be able to have something to set the table on. Here's the underneath. If you haven't spent much time or any time or ever assembling this extruded aluminum, gosh, you know, you're in for a treat. This is a puzzle. So before you just start grabbing the crap and sticking it all together, yeah, this is a little bit weird right there. Something's up there. Oh, look, it's not even. Oh, yeah, that's right. We haven't tightened the table down. Anyways, when you go to assemble this thing, you know, you put these in, you get the brackets on the corner here, and then all of a sudden, you know, you realize, oops, I forgot a few little track nuts here, so I got to take it apart again. Then you put it together again, and then oops, I forgot something else, and you end up having to take the whole and everything all apart again. Anyways, looking underneath here, make sure it's more cutting and, you know, a little bit more time and such, but you really want this table supported well, so span enough beams here to where your table is not going to sag. Again, this stuff here is pretty durable. It's nice and straight, but especially when you use this flat table stock here, it will sag over a distance. So support it good. So back to these gantry side plates. That's about the best name I have for them, I guess. This right here, if you want this to be, you know, even more stable, right? Not to say that it's not, again, right? We can separate this. Of course, you know, the more you separate this, the more stable it's going to become. But you have to kind of know when to call it, I guess. So the reason I called it right here is this structure here. If you look up and it tapers back, if you notice that this side right here is all straight. It's not a cantilever back or anything. It's just straight up here, and then this angle comes back like such, right? So this was cut out of. This is 6 inches wide, cut out of a 6-inch plate of 1/4-inch aluminum. If you want to go wider, you have to buy wider aluminum. So that's why I called it here, because I didn't want to you know, spend for the extra 7-inch piece, I guess, right? While I'm looking at this here, probably should mention these. So this was an afterthought, and now it's, you know, part of the normal operation of milling these things out. These holes are so you can get at the set screws in the bearing blocks that are back here. So whenever you buy these, take note that there is a set screw in the top of the block right here, and another one on the side. I know this is the top, but whatever, you know. And we've noticed that very frequently these are two different set screws with different, they take different Allen wrenches, so that's kind of an interesting thing. Any rate, if you want to get at these again, maybe you don't need to. You know, what we've been doing is Loctiting the little buggers and just running them up until they just touch onto the edge. I don't feel that, you know, by having them, you know, we really don't want any really torque or force on those, right? It just is going to cause more drag. But we have noticed that with even a small amount of vibration, they're going to fall out. So if you don't want to lose them, Loctite them in and keep these mounted up on the tops. Make sure you have holes in your gantry side plates here so you can access those later. And underneath here, gosh, I hope they're there. Oh, hey, look. See what I mean? It's already falling out. So, yeah, we'll have to Loctite that in there. So a little bit of detail here for those of you that might be trying to put your own together. What I have here is I have this top plate cut. This is about 2.5 inches wide. We used to have it longer, but we decided to cut it short because when it was longer it was overhanging here and it would hit. So this gives us, this will allow this to slide past these slide blocks right here, and basically it can go down to this point here. So it gives us a little bit more than a, you know, inch and a half or so more travel in the Z. Now this bracket under here, so here's our piece of angle stock, and so this holds it here. There's another one on the other side, but you see the supported rail right here. We had to put it in between. So essentially, you know, on this side here we got one full length, and then we have another one on the other side that's just about this wide that goes between the rail points. And these nuts go right through all three things, this thing, the plate, and the bracket on the other side. So then that sets us up to have a platform to be able to mount this plate on. Small problem here is that in order to mount these here on this bolt right here, this fastener has to be put on in this before you put this plate on, and because you see we can't get to it anywhere, it's countersunk into this plate right there, right? So it's a bit of order operations and planning ahead, but remember that. Now these, they used to be, they look like little H's we had to support the motor, and then we discovered that again the H's were with the wider plate, and so if we skinnied this up we couldn't put the H here anymore because the bolts for the motor, you know, there's nothing right here anymore. So we created this this little Z thing that we got, and this works just fine. Initially I was a little bit worried about just having the one bolt here until we realized that the third leg is actually this coupler and that anti-backlash nut and that collar down here that I told you about. So this is you know, I mean, this is not going to go anywhere. And on top of it, there's no force here with the collar and the anti-backlash nut here. All the support is all the downforce is taken up by that element here. The only thing that your motor should be doing is turning. That's it. Here's the feature I just finished putting together today. This is probably the one I'm least happy with. I needed something to hold this cable carrier, cable track up here, and I'm not a big fan of brackets and bolts and brackets and bolts and brackets and bolts. I don't want to just chain things together. So I don't know, it looks okay. I try to make it look as nice as possible, but for the sake of holding a plastic cable carrier, I had to, I'm taking advantage of the hole that was already here on the top plate here. So I got that there, And then right here you can see it's kind of wonked out there. Another fastener I had to put in there, but I had to tap it. And then there's a bracket right here, you know, obvious stuff. Come up here, go across. So I don't know, I gotta come up with something better for that. I'm not sure. Of course I could mill this whole thing out. I mean, this would be kind of a waste of material, but I could mill this out of a piece of, this is 6 inches wide, so I could get a piece of 6-inch stock and, you know, at least make this one piece right here and then bolt it onto there. I don't know. So by the way, the key terms for this, if you're trying to find this is really, gosh, I mean, it's pretty dirt cheap. I think you can get a meter for about 14 bucks. This is 10 by 15 millimeters. It's not much more for the wider stuff. So keywords being cable carrier, cable track, chain cable track, chain cable carrier. Try all of those different words when you're searching for this stuff. For those of you that are interested in the mounting system here, it's pretty simple. Mill these features out, so little flanges here, so they're easy enough to screw this together. I originally included another set of holes up here. This set of holes is so that I could separate this more depending upon your spindle. It'll give you a little bit more height, or you know, you could lower it down a little bit more. For these Makita ones, I wasn't planning for this, so it just fits in here, but I can't drop it down any lower. It'd be kind of nice if I could. So I really pretty much need to bring another set of holes down in here. But the more I get this whole contraption to stick out, the more any kind of wobble is going to affect everything. I don't want this thing overextended and have it chattering through the material. So rather than extend this way down to get down to the deepest, you know, part down all the way down to the table, I'd rather just bring the table up. So I'll just stack it up with, you know, some sacrificial layers or something to get up to here. Now, to fasten this, so here's our two pieces. Have your flange, put a fastener through here, that's obvious. And then take this, what we did on this, sometimes we drilled it through in counterboard and put the head this direction, and then we either tapped into this or nutted on the other side. This one, what we did is we just drilled through here and tapped this. So we got this tapped out, got the fastener that's the right length, right, and then we just ran it through. All the fasteners on here, by the way, again, like I said, we're pretty metric. So I have